Hey guys, this is Coach Brian bringing you the 6.2 pre-calculus notes. Today we're going to be introducing right triangle trigonometry. This is going to be some things that you were introduced to in geometry, and then it's going to build on some of those concepts. The first thing we want to talk about is when you have whole number sides that make a right triangle. Whole number sides that make a right triangle. So this is not unique. There are a bunch of these, but there are some that you will use really, really commonly. And these are called Pythagorean triplets. Pythagorean triplets. And it's good, just like it's good from last lesson, to know your perfect squares and be able to quickly, access that information. It's good to know these most common Pythagorean triplets. And so the most common ones are a 3, 4, 5, a 5, 12, 13, an 8, 15, 17. And then for these last two, I'm going to let you try it because you should be able to, if you don't remember these, use the Pythagorean theorem to figure them out. So this will be your A, this will be your B, this will be your C. See if you can find these two yourself. Now, moving ahead. In relation to theta, label the triangle. When we are doing trigonometry, it's always important to know your reference angle, which is normally called theta, or you might be given like the letters of it. But most of the time we'll be using theta, and you have to, make all of your label all of your sides and make all of your calculations and things based on that reference angle. So from this angle, the opposite side would be the side across from it. The adjacent side, I like to remember that as next door. Next door. That's the one that's right next to it. Okay, that's the adjacent side. And the hypotenuse is always going to be across from the 90. Okay, the hypotenuse is always going to be across from the 90. And this is a useful way of labeling triangles because it introduces us to the basic trig functions. Now, you probably have heard sine, cosine, and tangent. I know for sure you heard them if you've taken geometry here at Pierce. Cosecant, secant, and cotangent, they're used less, and you may not be as familiar with them, but they are just the reciprocals of sine, cosine, and tangent. So we'll talk about that in just a second. But we want to start with these side ratios. And you've probably heard the term SOHCAHTOA, and it's a way to remember your sine ratio, your cosine ratio, and your tangent ratio. Sine is opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. So again, these are all ratios, so it's showing the relationship of these two sides. The tangent is opposite over adjacent. That's where the TOA comes from, SOHCAHTOA. Now, we said that the cosecant, secant, and cotangent were reciprocals. Reciprocals are something that will, it's pretty much when you have a value and you put 1 over that value. Let's just say it's n. And so the reason, reciprocals mathematically, what they do is they cancel out through multiplication. Like if I had n over 1 and I multiplied it by 1 over n, whatever that value is, those would cancel out and your answer would just be 1. So that's what these reciprocal functions do. You can see right here, it's just taking this guy, the sine, and putting it under 1. Okay, it's just an official name for taking this value from over here and then putting it under 1. So another way we can think about this is actually taking this original ratio and flipping it. So instead of opposite over hypotenuse, or excuse me, instead of opposite over hypotenuse, it would be hypotenuse over opposite. And then same thing for the secant, we would just flip the original ratio. And for cotangent, we would just flip the original ratio. All right, so let's look at some examples. This says, using triangle CED, find the values of the 6 trig functions for angle C. So that's important right there, angle C. That is this guy. So let's put a theta in there to show that it is the angle that we are referencing. And then the 6 trig functions are sine, cosine, tangent, and then cosecant, secant, and cotangent. Those can be hard to remember sometimes, but the way, one thing that helps me is like sine starts with an S, and its inverse, or excuse me, its reciprocal doesn't start with an S. So we got a SC pair right there. And then cosine starts with a C, and its reciprocal starts with an S. So I got another CS pair. And then tangent and cotangent are pretty easy to remember because they both have the word tangent in them. Now, what we want to do is we want to start with the sine. And if you remember SOHCAHTOA, our ratios, sine is the opposite side over the hypotenuse. Well, the hypotenuse is across from the 90. In this case, it's side CE. And we do not know what it is. So how do you think we could figure that out? This is a right triangle, and we can find missing sides of right triangles using the Pythagorean theorem. So in this case, C is my hypotenuse. A and B are what we call the legs of my triangle. So we have the 2 legs. We can find the hypotenuse. 6 squared plus 3 squared equals C squared. 36 plus 9 is going to be C squared. C, if I found the square roots of both sides, C equals the square root of 45. And then I can simplify that, just like we did in lesson 6.1, into square root of 9, square root of 5, which is 3 square root of 5. So my hypotenuse is 3 root 5. So instead of having this unknown down here now, I know that it's 3 square root 5. Now, just like we talked about in 6.1, we would want to rationalize this. We do not want to leave this radical in the denominator. And so we would want to quickly cancel that out. And we would get, let me shrink this a little bit so I have some more room. We would get 3 square root of 5 over square root squared will cancel 3 times 5. Now, one thing I want you to get better at doing and better at recognizing is seeing when factors cancel out. Those 3's will cancel out, leaving me with square root of 5 over 5. Now, we can go ahead and jump to the cosecant because it is the reciprocal of the sine. So let's go back to the very original. Instead of having 3 over 3 square root of 5, it would be flipped, and it would be 3 square root of 5 over 3. And so I don't have to do any of the rationalizing, but I do need to cancel out these 3's, which leaves me with just square root of 5. Now for cosine, we want to use our adjacent side. That's our next door side. And we want to put that over the hypotenuse. And just like the first sine problem, we will need to rationalize this. And, excuse me, that will give us, I'm going to make that a little smaller. That will give us 6 square root 5 over 3 times 5. Now again, 6 and 3, right here, 6 and 3, they can reduce. So instead of 6, I can divide it by 3 and get 2, and then that will become a 1. And so my simplified answer is 2 root 5 over 5. Now for the secant, again, we would just go back to our original, and we would flip it. So 3 root 5 over 6. We don't have to do any rationalizing, but 3 over 6 is a half. So we would want to make sure we reduce that. And then lastly, for tangent, it is opposite over adjacent, 3 over 6. So all we have to do there is reduce to 1/2. Let me box these up because it's getting a little messy right here. 1/2, 2 root 5 over 5. Okay, and now for cotangent, we would just flip it, so it would be adjacent over opposite, which reduces to 2. All right, now for example 2, I'm not going to work all of these. I'm just going to do 1. I'm going to leave the rest to you. Then I'm going to work example 3 and be done. So we're almost there. Stick with me just a couple more minutes. Now, this says use the diagram of triangle SRT to find each side length. Let's use, let's do C, the hardest one. I'll grant you that. All right, so it says the cosecant of angle T. So I'm gonna go over here and put my theta here. And I need to define what cosecant is. I need to refresh myself for that. And it is 1 over the sine. So it's the reciprocal of sine, which is, sine is opposite over hypotenuse. So I'm actually going to flip this. It's going to be hypotenuse over opposite. So that's a good place to start. My hypotenuse of this triangle is the square root of 15, and my opposite is 2. Now, I need to find RT. That is the missing side right here. Now, again, I can just do this using the Pythagorean theorem. If I do not know the side of this triangle, the leg, I can just plug in the numbers I do know and solve for the unknown. Now, 2 squared is 4. B squared is still unknown. And the nice thing about this is that square root squared cancels out, and I'm just left over here with 15. Now, gotta keep solving for B, so I'm gonna subtract 4 from both sides. B squared equals 11. I need to get B fully isolated, so I'm gonna square root it, and I'm gonna square root this side. So I'm left with B equals the square root of 11, which cannot be reduced, and is my final answer. Now, for example 3, we're going to have to draw a right triangle to solve it. So let's go ahead and start with that step. Draw a nice little right triangle here. All right. So what they tell us is that the cosecant of theta is 5. So where is theta? It honestly doesn't matter. Pick any angle and make it theta. Then what is cosecant? Well, we actually just used this one on our last question. It is the reciprocal of the sine, which means instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. And it's 5. So that means if it's a solid even 5, that means it must be 5 over 1. Whoa, sorry. Must be 5 over 1, which means our hypotenuse, which is the side across from our 90, is 5, and our opposite side is 1. So we are looking for tangent of theta. Well, what is tangent? Tangent, if you can remember SOHCAHTOA, is opposite over adjacent. So what we need to do is find this missing side of our triangle, and then we need to find the tangent. So the first thing, finding that missing side, we're going to use the Pythagorean theorem. And so I know that my leg, one of them is 1, the other one I don't know, and my hypotenuse is 5. So 1 squared is 1, b squared is unknown, 5 squared is 25. And then I'm just going to go through the process of solving for b. I'm going to subtract 1 from both sides. B squared equals 24. I'm going to square root both sides. B equals root 24. I want to see if I can reduce that. I can, into 4 and 6. Why did I pick those numbers? Because 4 is the biggest perfect square that I can get from there. And that's just my missing side. That's what this side over here is. But that's not what the question's asking for. The question's asking for tangent of theta, which is opposite over adjacent. So I know the opposite side is 1. I know the adjacent side is 2 square root of 6. And then I hopefully recognize that I need to rationalize this. So 1 times the square root of 6 is square root of 6. Square root squared cancels, so I've just got 2 times 6 down here. And that means my final answer is root 6 over 12. All right, you try the next section on your own, and hopefully this helped you as we introduce trigonometry.